first thing we're going to do is change the word use to without. Without a graphing calculator, we are going to graph y equals log base 8 of x. So I introduced you to graphing logs the other day, and we're going to be able to do it again. Okay? For all of your log graphs, you need to know the two key points that happen on a log graph. Key point number 1 is it always goes through 1, 0. And since the base is 8, can you tell me an x value that's easy to do mental math with? 8. Log 8 of 8 is 8 to what power is 8? 1. So log graphs always have this shape. They also always have an asymptote at x equals 0. And we have the graph of log base 8 of x. Identify the intercepts. Well, there's only one intercept, the x-intercept, and the x-intercept is 1. There are no y-intercepts because of the asymptote. The equation of the asymptote is x equals 0. Some words you shouldn't abbreviate. The domain and range. So our function for the domain, all the x values are positive. Since there's an asymptote at 0, it can't equal 0. And our range is everything. So 7a, what we are going to do Monday after the quiz, so reminder you have a quiz on Monday, is we are going to graph stuff like this. Y equals 2 log 3 of 3x plus 9, let's do 12. 3x plus 12 minus 5. How do you do this? The same way you've done all of your transformations up till now. Step 1, recognize the parent graph. What's the base graph of this one? We'll graph it off to the side here in green and label it. The base graph would be, it's a log graph, a log of base 3. So the base graph is a log of base 3. So the thing that we have to realize is that the log, the 3, and the x, that's our base graph. The part that makes it tricky, just like exponentials, is one of the things in your base graph is a number. Sometimes you're tempted to make that 3 part of your transformations, but it's not. It's part of your base graph. And since we have a log 3, we know that log graphs look like this. We know we have the point 1, 0, and 3, 1, with an asymptote at x equals 0. There's our base graph, our parent graph. And now we're going to take those points, 1, 0, 3, 1, and our asymptote, and go through our transformations. Moving from left to right, all of our stretches and compressions, what's going to happen? I'll do the asymptote at the end. What is going to happen to your x and y values for stretches and compressions? You're going to multiply y by anything? Wow. Yes, we're going to multiply y by 2. X by anything? 1/3. So what happens to this point? We get 1/3, 0, and here we're going to get 1, 2. Nice. What about moving things left and right? We're going to move left, how many? 12? Left, how many? 4. What? Yeah. No, because this part right here looks like a 4, doesn't it? Sideways, so then you do 4. That's the mathematical way we do things, right? Doesn't it look like a 4, kind of curly? Okay, no, that's not the right math. Yeah, you have to factor it. Horizontal stretch with a horizontal translation. So it might have made, we probably should have recognized that right away and factored out that 3 and gone left 4. And we're going to go down 5. So if I go left 4 and I have 1/3 and I go left 4, I'm going to get at -11/3, -5, and -3, -3. And your asymptote will go to x equals -4. And now that you have those new points and your new asymptote, you could graph it. But since the bell goes, we won't put it up.